So today we're going to use an existing print to produce a 3D shape in Solidworks. Here you can see a GD&T drawing. This is a top view, side view, and detail views. And those of you who may not be familiar with it, this is what's known as a collet. And it's used to grip parts. This one is used to grip the inside of a part using the outer diameter of the collet. So here we've opened up SolidWorks. We're going to start a new file. We're going to set up in metric as a part file. And we're brought into this workspace. Down here on the left, you can see your orientation. Later, if you go into an assembly drawing where you're bringing in multiple parts, you can actually change this orientation to make them all reference the same axis as up and your plane surface. So we're going to start by going up to Sketch, and we're going to use this Create New Sketch. And because we haven't created any geometry in this file yet, we'll be prompted to select a surface. Now I'm going to just select Front, and it'll automatically position me normal to that plane. If you ever lose orientation, you can click this button here, and it'll make you normal, or rather faces you dead on to that plane. So you can see here, I've changed the angle at which we're looking. Click the normal button, brings it right back. So we'll start by drawing half. You can see the center line here. We're going to use the center line to do a rotate feature. This is a round geometry. So we're going to draw half of it, roughly. Then we'll dimension it and revolve it in order to get a general shape. After which we'll bring in these details, and then we will draw these feet, which are noted from a top view rather than a bottom view, which is unusual, but doesn't matter. The feet are these details down here. You'll see that as we get closer to completion. So let's start by creating 1, 2 steps out, 1 step in, 1 and 2 steps back out. Well, since we're going to be creating those feet, actually let's do that as an additive feature, not a subtractive, which gives me something good to talk about. There's 2 schools of thought here. You can either make a cylinder and you could subtract all of the geometry to create the shape, or you could create it and add onto it. So for example, I could create this profile without the foot, just have this flat face, and add the foot in later, rather than creating this whole geometry and then having to remove the material that I want in between the feet gone to create these feet. It's just a different way of doing it. You can do either. Neither is more correct than the other. So let's start here. I'm going to start with a center line, and it's giving you rough units there. And you can see our overall part is 82 millimeters tall. So we'll create a center line that's only slightly taller. And then we will start drawing our actual geometry. This reference geometry denoted by the dashed line will actually not be turned into real geometry. That's just for reference. So we can see here this is hollowed out, and you can see that by the giant void that's created here, and it's on an angle. So it gets larger as it goes down. So we're actually only going to create this geometry here and then revolve it. So what we're going to do is just click, drag, and click to create a point and a line. And like discussed, we're going to create this one shelf and add this in later, going back in and doing 2 steps out. So we're up, we're in, we're out, up, over, up, and over. And that creates our rough geometry. We'll add in a lot of these extra details as we go. All right. So our first definition here is how far we are away from the center line. And because we're only doing half the geometry, all of these dimensions will be automatically half in our drawing. So this point from the center line is only 16 millimeters. We can start with that. So this point, we can click it, you click the center line. Using the Smart Dimension tool right next to the new Sketch tool, Smart Dimension. And it's going to ask you, when you place down that point, what you would like for a definition for the geometry right there. So we're just going to go for an exact 16 units because we haven't defined it, but the file itself is set up for metric, so it automatically assumes millimeters. If you wanted to, you can actually add that in. This works also if you're in other units. If you've set up your file format for inches, you can still type in millimeters and it will auto dimension that into inches. Now another useful starting geometry would be this overall height. So we have 82 millimeters denoted from this surface to the next over here. All right, and then we have this first step. See that is 42.4. So that becomes half. 42.4 becomes 21.2. Essentially, we're going to reproduce these sketches in SolidWorks and then use the 3D functions to make it more understandable to our three-dimensional understanding of objects. Okay, so this next shelf down here is at 51.5. You can also use the tool calculator by using equals. So if you have 51.5 and maybe you're having a slow day and you can't do math in your head, you can use the calculator, divide it by 2, and it'll automatically figure that math out for you. There you go. And you can see here it's put in a symbol to let you know that it's using driven mathematics, which is denoted by the equal sign. We could have done this for all of the dimensions, but this is more of an overall crash course on the basic features. So again, 69.55 for this outer surface. 69.55 divided by 2. There you go. And this last couple of dimensions down here. So the bottom point is 48.2. Apologies, did I say 48.2? I did say 48.2, and that is what it is. So equals 48.2 over 2. There you go. And then we're going to use this dimension for the outer wall because we're skipping the foot. So that's 56. So equals 56.2. Nope, just 56 divided by 2. So now that we have all of these outer dimensions defined, we need to define the heights of each piece. So we zoom out here. We can see we're given dimensions for how tall each one of these surfaces are. So our top shoulder is 3.8 millimeters. You can just click the line. 3.8. There you go. This surface is denoted as 30 from top to here. 30. And then this is 6. You notice the color of the lines changing. Blue is undefined, and black is fully defined. Lines and points can be defined. So you see here, this point is blue, which allows me to move it wherever we please. But the line is black, which means it will never change orientation. We now have the basic geometry of this created. So what we're going to do is exit the sketch. This will save and close it. Now we can select it over here on this is called the feature tree. So if you select it, you go features, there's a number of 3D operations you can perform here. And we're going to use Revolve. Because we already had our sketch selected, it's made a couple of assumptions. It's taken our sketch, and it's determined we would like to revolve it around this construction line, the center line that we drew, which is correct. Now, if we wanted to set this up manually, we would go to Selected Contours and select the shape we drew, and then go and click Axis of Revolution and select our center line, and we would get the same feature. Generally speaking, Solidworks does a really good job of recognizing what it is you'd like it to do. So we have this basic feature that we've drawn in. We're going to add these two details. They're cutaways to allow the metal to be flexible. So we'll start with this one. We want to draw in such a fashion that we can cut through this geometry. So we can use either the front or the right face. Because what it'll do is once you've drawn on this face, we can extrude it to cut through the existing geometry. So we'll go to Sketch with the right plane selected and create New Sketch. Notice it automatically makes this normal to the view. And we can start drawing this feature here, which is simply a cutaway with a circle dangling at the end. So what we can do is we've created this circle, just clicking a point and dragging out. I've left it undefined. You can define it as you're working, or you can define it later. So we already know that it's 7 millimeters in diameter. So we'll go ahead and define that. And then we have a cutaway going through the entirety of the part. So what we want to do is, with our line tool selected, we can click and drag. And notice here it's showing in yellow that the line is completely vertical. We can just click and go over. And again, with a yellow vertical orientation, we can click on the circle. And you notice next to the yellow line, it also has a yellow point. This means that it's going to be joined to the circle at the end point of that line, which is exactly what we wanted. Now to get this piece here to get cut out, we're going to use the trim feature. And all you have to do is click and drag, and it'll remove any lines that are in the way. Which is perfect. Something else you can do is constrain features. So if you click a line, you can get all sorts of information for it. And if you're not giving it a constraint in relation to something else, it'll call it just a relation to add. So currently we can see it has a vertical relation. We could also give it a fixed relation, which would let us not move this around anymore. So, but I'm going to Shift-click this other line to select both of them, and we can see we can add relations between them. For example, we can make them equal, so that if we define one, we automatically define the other. Now from the drawing, we know that the distance between the lines is 1.5, so let's go ahead and put that on in. Good. And we know that both lines are equidistant away from the center of the circle. And that the middle of the circle is about the axis of the part, and also 8 millimeters from the bottom about the center of the circle. So we select the middle of the circle, select the bottom, 8 millimeters. And then in order to make this go through the center of the axis, we can select these 2 points and make them vertical to one another. Notice how the lines all turn black. It's now fully defined. The only undefined portion being this small piece here at the end. Now we don't necessarily need to define it, which is why it's left undefined on this drawing, because it goes all the way through. But we can also define it if we choose, just to make sure that the sketch is fully defined. So we'll make it slightly larger, and now we have a fully defined sketch. We can exit this one. And now notice the plane that we drew on is through the center of the part. Now this doesn't actually pose a problem because we can do an extruded cut through and out of the part. So we're going to use extruded cut. You can see it starts to generate the profile for what it's going to do. And we can manually click and drag, and it'll give us a preview of what it will cut out of our geometry. Or we can use a couple of features here on the left to make it more precise. Blind means it'll just cut until you tell it to stop, in this case 70 millimeters. What might be better is to just simply tell it to go through all, and it'll automatically define that for itself. And there's a number of other features here that you can use to do more precise operations. You can have it go up to the next surface, to a specific vertex, up to a specific surface, and a whole bunch of other features. I tend to just use through all on individual parts, seeing as how it's not going to cause a problem because it's not an assembly. So we have this cut that we've now produced through. And we can see from the drawing, there's actually 6 of these cuts that are all 60 degrees opposed from one another. And we will do the exact same feature with this other cut, and that's 30 degrees opposed, also times 6. Now, we can do 2 things. Either we can use reference geometry in the part and add in a 30-degree bias to the right plane that we drew on. So it would create a plane with a 30-degree offset in the same direction. Alternatively, we can use geometry to determine the fact that with 6 features being revolved all the way around at 60 degrees between them, we know that there's also an offset between these 2 cuts of 30 degrees, also with 6 features, which means that when we revolve the 6 cuts by using like a circular pattern, we can do right now. So we can pattern our cut by using the featured pattern as our extruded cut, and then selecting the y-axis about which we would revolve. Now here, it's the number of instances to create and the number of degrees to oppose them. So we know that we have a 60-degree opposed, and we know that we have a total of 6 features. There it previews the geometry that it's going to create. Now this is one way of doing it. The other way to do it would be to select 360 degrees in this field and click equal spacing with 6 features, and it would automatically determine that, well, a full revolve is 360, you have 6 features, they must automatically be 60 degrees apart if they're equally spaced. We can see here, there's new geometry that's been created. So, but now knowing that we have these 6 features, all at 60-degree intervals, and the other features need to be 30 degrees out of phase with these, we know that if this is 0, and our first instance is at 30, and the plane is at 90 degrees, that means after a 3/4 revolution, we'll actually be on the front plane. And you can see that as the front plane bisects these 2 features. So we're going to click the front plane, and we're going to sketch. We're going to create this feature here. Again, pretty much the same, a cut all the way through with a step and a circle at the top, again with the same definitions. So we'll create our circle. It is deciding to auto dimension things, which we don't need. There we go. And then the shoulder breaks out and gets wider. Goes all the way through. There we go. So we've got the rough geometry. Again, we're going to trim that circle. We'll make these 2 equal. We'll make these 2 collinear. You can see exactly what that did. You can also make these equal and these as well. It just helps with the speed of defining all of the features. So that neck is 1.5, and the distance to the top is 7.5. So got 1.5. The center of the circle at the top is 7.5. And the size of the circle is 7 millimeters. Sometimes it'll do this and it'll come up with a radius. The radius is just half the diameter. There we go. Now, I also need to define the length of this wider cut, which is 4 millimeters wide. So I'll go 4. And then the length of this cut is 56.1. 56.1. And then again, we'll select the middle of the circle and the origin, about the axis. We'll make them coincident. Sorry, not coincident. We'll make them vertical. That'll fix our issue. Now, because we have a defined length for this cut, we actually need to make the bottom of the cut collinear with the bottom of the part, so that this piece here is automatically defined. And our whole drawing is turned black. That means it's fully defined. We can exit our sketch and do the exact same thing as with the previous feature. We'll do an extruded cut. Go through all. And then we can pattern this feature in the same fashion. There you go. So now we've got the basic of the collet finished. We'll need to create the feet. The way we can do that is by looking at the part on the bottom. Now you may have created the geometry in an arbitrary point in space, so this top plane may not always be a good starting reference for where you'd like to draw. In this case, it happens to be in the right place, but in the event that it isn't, what you can do is you can start a sketch on geometry you've created, like the bottom of the part. And as previously, it makes you normal to the part. And we can start drawing in these feet. We'll have to pull some of the dimensions off of other parts of the drawing because it's not all shared within this portion of the drawing. We can see, for example, that the height of the feet comes from this portion of the drawing. And that there's a couple of little details like radii and chamfers that we need to include that are detailed out on other portions of the drawing. So now I'm going to draw in these feet, and there's a couple of ways you can do this. You can draw the actual geometry, or you can draw out the rough geometry and then radius and chamfer. So I'm going to do the latter. So we have 15 millimeters across, centered about that bottom cut. It's 8 millimeters tall, and it sticks out from the face. So we can start drawing here, and it is oriented to these bottom cuts. The feet straddle these cuts. So the easiest way is going to be to simply draw two squares. Like this. Now we know the distance between them from the outside is 15 millimeters, as denoted here. And the cut between is going to be the width of this cut. You can see the 2 feet straddling this cut. So we know that these lines need to be equal, and also they need to be collinear with the cut. So we made both of those collinear, and you see it automatically made them equal length. These can be collinear, and so can these. Now let's make sure I'm defining the stick out correctly. So it's from the center line. All right, that means we go from the origin, and we're going to make it stick out 34 millimeters. There we go. And then as long as the back part of the feet is within the existing geometry, it doesn't matter, because once it gets extruded, it'll become part of this feature. So at this point, even though this is undefined, we can exit the sketch. And with our sketch selected, we can use our feature and extrude. Important here is the direction. So we don't want to extrude the feet down, we want to extrude them up. So we can click this button to reverse direction. And we know from the drawing that it stands 8 millimeters tall. So we'll change this to 8. There we go. Now I've got some feet. Now we could use the circular pattern to create this all the way around the part, just like we did the cuts. But before we do that, let's finish out the geometry as it's shown in the drawing. So we have a 45-degree chamfer. I believe that denotes 2mm chamfer. So if you click here, the chamfer and the radius, chamfer and fillet tool, which creates radii, are under the same thing. So if you click chamfer, you click your edges that you want chamfered. So we want these two. And then we select a 2mm chamfer at 45 degrees. Perfect. It's gone ahead and done that. And then we're going to use the fillet tool, create a radius. Here, a radius of 3mm on both of those corners. So we'll select there. We'll select there. 3mm. And all right. And there you go. So those have all been created. Now we also know from this drawing that there's a radius of 0.5 at the top of the foot. Additionally, you can see there's a broken edge denoted by a tiny chamfer. So we can do the same. We'll use the fillet tool. And fillet those two surfaces with 0.5mm radius. There it goes. And then we can also use the chamfer tool to break these edges. We're going to use 0.1mm. So it's just a broken edge, it's not a feature. There you go. Now your feature, your Extrude 3, has been fully created, and now we can multiply it by 6 by again using the circular pattern and using the central axis to create those feet. We've already got 360, 6 features and equal spacing, and an option down here is to see various previews, but somewhere in here, I can't remember where, but it'll ask you if you want it to be part of the geometry or not. Anyway, so we'll go yes. Oh, don't want to do that. There we go. Features to pattern. It was confused. And it didn't copy all of our orders here because these are done externally to that feature. So we can go back in by clicking it on the tree and going edit feature. And then we can select the additional features, the chamfer 1, fillet 2, and chamfer 2, to make those also be repeated across the geometry. And then click OK. That looks much better. And there you have it. It's a basic collet drawn up in Solidworks. You could also, if you wanted to, edit the material for this. Solidworks comes with a number of different materials, and here you can see a variety of different types of steel. And if you have it on your build print, you can actually find the material or you can program it. But for this particular one, we're using an A2 tool steel. You select it, apply, close, and you can see it's done a visual change, but it's also assigned it some properties. And so it's given it weight and density and a couple of other metrics. So you could go to evaluate and use this mass properties tool to estimate how much your tool is going to end up weighing. Right here, it lets you know it's going to weigh about 3/4 of a kilogram. So a little bit more, or a little bit under rather, a little bit under 2 pounds. This is just a useful feature. Well, thank you for watching. I hope you learned something. Otherwise, take it easy.